Today, we're diving into a story about one single machine. But this isn't just any machine. It's so complex, so unbelievably powerful, that it's become the centerpiece of a global power struggle that could, quite literally, reshape our world. I know, it sounds like something straight out of a sci-fi movie, but this is happening right now. Think about the original Manhattan Project, right? The US gathered all its top scientists in secret to build one thing. Well, China is doing the exact same thing, but they're not building a bomb. They're building what might just be the defining weapon of the next century. Just picture this for a second. A top secret facility where the engineers all have code names. They're totally cut off from their families, working 24/7, and their whole life, their whole purpose, is to build a machine that makes a special kind of lamp, a magic light. So you've got to ask, right? What on earth is this light, and why is it so important that a country would pour billions of dollars into it? Well, the answer is probably sitting in your pocket or on your desk right now. It's inside every single piece of tech you own. Because this magic light is the one and only key to creating the most advanced microchips. You know, the brains that power literally everything, from your smartphone to a fighter jet. So let's break that down. A microchip is basically a tiny, tiny city packed with billions of microscopic switches. We call them transistors. And for decades, there's been this thing called Moore's Law, which basically said we'd get twice as many of these switches onto a chip every couple of years. More transistors equals more power. But to keep that up, well, we've had to shrink them down to a size that's just almost impossible to imagine.
Just how small are we talking?
Well, the most advanced ones today are just 3 nanometers.
Okay, 3 nanometers. What does that even mean? It's a number that doesn't really compute in our brains, so let's try to put it into perspective.
Okay, think about a single strand of your hair. It's about 50,000 nanometers wide. That means you could fit almost 20,000 of these transistors across the width of one hair. I mean, we're not just talking small anymore. We are literally building things at the atomic level. It's insane! So the next logical question is, how in the world do you draw something that tiny? You'd need a pen with an impossibly fine tip, right? Well, in chip making, they have one. That pen is light. The whole process is called lithography. And the basic idea is simple. The shorter the wavelength of the light, the thinner the line you can draw. And that is where our magic light comes back into the picture. But here's the catch. Creating this ultra-fine, ultra-short wavelength light isn't just hard. For a long time, it was thought to be impossible. The tech is so mind-bendingly complex that it created one of the most complete monopolies in the history of business. And it's all controlled by one single, very unlikely company. That company's name is ASML, and they're not in Silicon Valley. They're based in a quiet little town in the Netherlands. And when I say they have a monopoly, I mean it. They're not just the market leader, they are the market. They control pretty much 100% of these incredible machines called EUV machines. That stands for Extreme Ultraviolet Lithography. And that means they literally hold the keys to the entire future of technology. And what does one of these keys cost? Get this. A single machine will set you back $350 million. And it's an absolute behemoth. We're talking 180 tons of the most delicate, complex engineering on the planet. It's so big and so fragile, it has to be shipped in 3 separate Boeing 747s just to get it to the customer. Okay, so how does this thing even work? This is where it gets absolutely wild. So inside a total vacuum, the machine drops a single, tiny droplet of molten tin. A laser hits it once to flatten it out like a pancake, and then a split second later, a second, way more powerful laser completely vaporizes it. This creates a plasma that's 40 times hotter than the surface of the sun, and that plasma is what finally gives off the magic EUV light. And here's the craziest part. This whole thing, it happens 50,000 times, every single second. The light it creates is so fragile that basically anything absorbs it, even air. You can't use glass lenses, so it has to be guided by a set of mirrors. But these aren't just any mirrors. They are the flattest, most perfect surfaces humans have ever created, made by one company, Carl Zeiss in Germany. To give you an idea of the precision, if one of these mirrors has a tiny flaw, just the size of a single atom, the entire batch of chips is completely ruined. This is, without a doubt, the most complex machine humanity has ever built. Period. So, you can imagine a machine this critical, it's not just a piece of tech. It's a strategic asset, and it very quickly became the central piece in a new kind of global conflict. Once the United States fully grasped what this machine meant for military power, for economic dominance, well, they decided they had to do something about it. Starting around 2018, the US started leaning hard on the Dutch government. Their message was clear: treat these EUV machines like they're nuclear weapons. Do not sell them to China. And by 2022, the ban got even tighter, expanded to include even older machines and essential materials. The goal was crystal clear: put a technological chokehold on China. The plan was to freeze their progress dead in its tracks. Now, from China's perspective, this wasn't just some trade squabble. This was an existential threat. They saw the West trying to lock them out of the future of tech, the future of their economy, the future of their military. So Beijing's response was massive. They launched an all-out national mission to break this blockade, no matter what it took. First up, money. Lots and lots of money. A state-backed investment fund, they call it the Big Fund, dumped more than $47 billion into this project. And that was just the start. You're talking huge tax breaks, free land, basically a blank check for anyone who could move the needle. But as they quickly learned, you can't just buy this kind of know-how. So China got creative and, frankly, a little ruthless. They launched this huge campaign to poach top engineers directly from ASML, waving around seven-figure signing bonuses. At the same time, they were taking apart the older machines they bought before the ban, piece by piece, to reverse engineer them. They set up shell companies in other countries to try and buy the restricted parts secretly. They were even reportedly trying to source components from the black market. And then it happened. News started to leak out, and it sent shockwaves through Washington and the entire tech world. Back in that secret lab in Shenzhen, a team of Chinese scientists, helped by some of that poached talent, had done it. They had achieved what so many in the West thought was impossible. They had built their own EUV machine. It was clunky, it was crude, but it worked. The magic lamp was lit. This was a huge, huge win for China. A massive breakthrough. But it didn't mean the race was over. Not by a long shot. See, proving you can turn on the lamp is one thing, but using that light to reliably make millions and millions of perfect, profitable microchips, that is a whole different ballgame. The final and maybe biggest hurdle is a concept called yield. And the best way to think about it is like baking cakes. ASML's machine is so precise, it's like a master baker. You put in the batter for 100 cakes, and you get 90 perfect cakes out. That's a 90% yield. You're making money. Now, China's prototype, it's more like a clumsy beginner. You put in the batter for 100 cakes, but maybe only 10 come out okay. At a 10% yield, you're not making money, you're going broke. Closing that yield gap, getting from 10 perfect cakes to 90, is now China's #1 obsession. And let me tell you, the stakes for them pulling this off are astronomical. For two big reasons. First, Taiwan. Right now, Taiwan is protected by something called the Silicon Shield. Their main company, TSMC, makes over 90% of the world's most advanced chips. If China invaded, the world economy would grind to a halt. But if China can make its own advanced chips, that shield disappears. Second, AI. The entire AI revolution is built on chips from companies like NVIDIA, chips that are banned for sale to China. If China can make their own equivalent, you're looking at a full-blown AI arms race, and nobody knows where that leads. And that brings us to the great irony in all of this, doesn't it? The US put this blockade in place to stop China, to freeze them in place. But what it actually did was light a fire under them. It gave them the national focus, the motivation, the reason to pour everything they had into achieving the impossible. The attempt to kill their chip industry might be the very thing that ends up making it self-sufficient. So, make no mistake, a new tech Cold War is already here. It's not being fought with tanks and spies in the streets of Berlin, but with lasers and mirrors inside a vacuum chamber. And at this point, the question really isn't if China will eventually break ASML's monopoly. It seems to be a question of when. And once that happens, who gets to write the future?